Welcome to Chapter 4, Unit 2, and we're going to talk about the unit circle here. And this is really the foundation of trigonometry, and it's really important that we get a good grasp of this. And just as a fair warning, it's going to be confusing at first, and it's not going to make much sense, and that's okay. You got to give it some time, and we've got to work through it and try to break it down into smaller pieces so you can understand little pieces at a time. All right, so in the unit circle, we're going to start with a circle, and we're going to look at these angles that we've looked at so far. And we're going to deal in radians. So we've got this circle, and it's divided up, and the key angles we're going to focus on are 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay, and all of those angles repeat in each of the quadrants. So 2 pi over 3, well, that's just pi over 6 from pi over 2, and 3 pi over 4, that's just pi over 4 from pi over 2, and 5 pi over 6, that's just pi over 3 from pi over 2, and then pi is just pi over 2 from pi over 2. So these continue to repeat all the way around the circle, and so we're going to notice some symmetry with those. All right, now let me give you a physical representation of this using a Java applet. So I want you to picture a circle that has a radius of 1. Okay, and we're going to say at the center of the circle is our origin, and so we can find these central angles if we connect from the origin to this point out here. That creates an angle of pi over 4, and this right here is an angle of pi over 2 and 3 pi over 4 and pi, and so on and so forth. And I want you to focus on two things. If we connect the center to the circle, that creates a radius. Well, that radius can have two components, a vertical component, meaning up and down, and a horizontal component, left and right. So how far above is the blue dot from the red dot, and how far to the right or to the left is the blue dot from the red dot. And so as this blue dot moves around the circle, notice what happens to these two components. We have a horizontal component that is getting smaller as we move across, and then ends up getting bigger, and a vertical component that starts to grow. It was once 0, and now it's up to a full radius right there at pi over 2, and then it starts to decrease into 0 at pi, and then so we're seeing that blue piece get bigger and smaller as we go around the circle. So we have these vertical components, the blue here, and the horizontal component, the orange. And if you notice the nature in which this changes, if you look at just the orange, how it gets bigger and it speeds up, but then it's slowing down to where it gets to its longest length over here, and then it starts to speed up and then slow down again, and it goes through this periodic motion. And really, we're going to introduce these trig functions that help to describe this periodic motion. Okay? So I'm going to define 3 functions for you. Now, these functions are called sine, cosine, and tangent. And so to actually write those out, that's S-I-N-E. That's sine, and we represent that with an S-I-N. And then there's cosine, which we represent with a C-O-S, and a tangent, which we represent with a TAN. Now, you might be thinking tangent, oh, it touches at just one point. Well, it's not quite the same thing. We're using the word a little differently here, and we'll expound on that a little later. But when we talk about the sine of an angle, when we're dealing with this unit circle here, so the sine of an angle, sine is a function that we put in an angle and it spits out a value for us. Okay, so we put an angle like pi over 4 into the sine function, and it spits out a value. The value it spits out is radical 2 over 2, and we'll get to that in a second. But what is that actually telling us? Well, that's telling us this vertical distance here. So at any point on the circle, we have some angle theta. The sine of that angle tells us how high is our point off of the x-axis. Or if we're down here, say down here, how low are we below the x-axis? Okay, so sine corresponds with the y. It corresponds with the vertical component of this triangle. And we'll deal with right triangles a little more in the later section, but that's really the definition here. The vertical component of the point on the circle. Where cosine corresponds with the horizontal, it corresponds with this piece right here. You know what, let's make it a different color. It corresponds with this red piece. Okay, cosine is this red horizontal piece. So at that point, how far are we to the right of the origin? Now we know that the exact distance between these two is just the radius of the circle, which in a unit circle, that's always and forever 1. All right, now how do we know that x, y, and r relate? Well, we know that this is a right triangle, so the Pythagorean theorem comes into play here, and x squared plus y squared equals 1 squared, which in this case is just 1. So we know that these two are related here. The sine of theta, whatever that is, squared, plus the cosine of theta, whatever that is, squared, is always going to equal 1, all right, because of our unit circle. So based on this definition, we can figure out, well, that point has a coordinate, an x-coordinate and a y-coordinate. We can find that x and y coordinate using these trig functions, and that's what we call these. These are trig functions. These are 3 of the 6 that we're going to learn. All right, we'll learn the other 3 in class tomorrow. Okay, but these 3 deal with this unit circle here. All right, now we talked about sine, we talked about cosine. Well, what's tangent? Well, tangent actually is just the ratio of the two. Another way to think of tangent is tangent of theta is just whatever sine of theta is divided by whatever cosine of theta is. Now, theta can be anything. I mean, it's just an angle. It could be pi over 4, pi over 3, pi over 6, 8 pi over 7, whatever it may be. And if we want tangent of that, it's just sine of that angle divided by cosine of that angle. Or, in other words, the vertical component, ry, divided by the horizontal component, the x. So let's talk about those special angles that I mentioned earlier. And the special angles we want to remember are 0, pi over 6, pi over 4, pi over 3, and pi over 2. Now, these are the what we call the reference angles that we're going to use, because we can in some ways, rewrite all the other angles in terms of these, and we'll explain how we do that later. But we're just going to focus on these 5 angles here. Now, if you want to know, well, what are these in degrees? Well, we can rewrite these. This is 0, this is 30 degrees, this is 45 degrees, this is 60 degrees, and this is 90 degrees. You might ask, well, what's so special about these? Well, these are special angles that show up in geometry, right? 90 degrees, well, that's a right angle, that's perpendicular, pretty important angle. Okay, we use that a lot. 30 and 60 go together because they form a 30, 60, 90 triangle. And 45 comes into play because of the nice symmetries that we have of a 45, 45, 90 triangle. Okay, so these are all of our angles, theta. All right, now we can prove all of these values using those triangles from geometry, but right now I'm just going to tell you what they are. Okay, so if we have all these angles here, and we want to look at what is sine, what is cosine, and what is tangent of each of these. Now, you definitely want to write these down, and in fact, you're going to need to commit all of these to memory. Okay, so sine of 0, that's what we're asking here, sine of 0. Now, what that is looking at in the unit circle, that's looking at when our angle is 0, so we're at this point, our angle is 0, so we're looking at this piece. How high are we above the x-axis? Well, we're nothing above the x-axis. We're at a height of 0. So sine of 0 is 0. All right? And then sine of pi over 6, what we're talking about here is how high are we above the x-axis. So if we want to look at a reference here at pi over 6, so it's a little below here. It's more like right here is pi over 6. So how high are we? What's this distance right there? Well, that distance is actually 1/2. It's half of the way up to a full radius. And then pi over 4 is radical 2 over 2. And you might say, wait, where is this coming from? Once again, you can use geometry to confirm this. I'm not going to do that on the video here, but you can use a 45, 45, 90 triangle to confirm this. All right, this is radical 3 over 2, and this is 1. Sine of 90 is 1. And let's confirm that from the unit circle here, in that pi over 2, when we're at 90 degrees here, well, what's our vertical component? How high are we? Well, we're 1 full radius above, and so that's just 1. And then when we start going down here, we start repeating these same values. Now we're to radical 3 over 2, and we're at radical 2 over 2, and then we're 1/2, and then we're back down to 0. And then we continue to repeat those values, except we become negative over here for our y values, okay? So that's sine. Sine of pi over 6 is 1/2. Sine of pi over 4 is radical 2 over 2. Sine of pi over 3 is radical 3 over 2. Sine of pi over 2 is 1. Okay, cosine, you'll notice, well, this is our horizontal component. So when we're right here, how far are we from the origin? Well, we're a full radius. So we're at 1. So cosine of 0 is 1. And then you'll notice the same thing happens. Our horizontal starts to shrink, and then we go to radical 3 over 2 and radical 2 over 2, and we get 1/2 and 0. And notice the symmetry here. Cosine goes from 0 up to 1. Sine goes from 0 up to 1. Cosine goes from 1 down to 0. And they hit the same values in between, and they match up, and they're actually the same at pi over 4, which is 45 degrees. Now, tangent, remember, is sine over cosine, so 0 divided by 1 is 0. All right, 1/2 divided by radical 3 over 2 gives you 1 over radical 3, so if we rationalize that, that's radical 3 over 3. This gives us 1. This gives us radical 3, and this is undefined, or it does not exist. And that's important, okay? Sine and cosine are defined for all values, where tangent is not. There's parts where it's undefined, and that's when cosine is 0. Okay, in class tomorrow, I'm going to teach you a couple techniques of how to remember this table here, and a few tricks using counting and using our hands a little bit. But what I want you to do is I want you to fill in as much of the notes as you can. You might not be able to fill in all of it, that's fine. Come into class with some of the notes filled in and try out some of those examples in the guided notes. And all you're doing is evaluating, what is sine of pi over 3? What is sine of pi over 2? And looking at the vertical and horizontal components.